So we are going to start talking about matrices in this unit. We're going to do a really fast, short little unit on them. So for those of you who don't know what a matrix is, matrices is the plural, so we have our definition first. So a matrix is a rectangular array of numbers or quantities. And these quantities must be able to have mathematical operations performed on them. So something that you could do like addition, subtraction, multiplication, division, that kind of thing with. And we would say that an element or an entry is a quantity inside the matrix. So one thing that's really important about matrices is they have different dimensions. So we want to have our dimensions in the correct order. So dimensions for a matrix are the number of rows by the number of columns. So an example of a matrix, we'll call this matrix E. So normally matrices are given names with capital letters. We could draw this matrix right here. So matrices are inside of square brackets, and they are just rows of numbers. So we could say E is a matrix, and it has 2 rows and 4 columns. So this is a 2 by 4 matrix. And each of the different elements inside is what we call an element. So like 17, 22, 17, 16, those are all individual elements of this array or this matrix. So we have matrices, and then we have something that is called the transpose of them. So the transpose of a matrix is found by interchanging the rows and columns. So you just switch the rows and columns. Whoops, totally missed a word since I was talking and writing at the same time. By interchanging, there we go, the rows and the columns. So using our example of matrix E above, we could say the transpose, which we label as the same name, we give it E, but then you put a capital T exponent there, so superscript. So E transpose is, so 17, 22, 17, and 16 are in the first row of regular E, so in the transpose they would be the first column. So now you just put that row vertically, and then the second row would become the second column. But other than that, the entries don't change, the elements all stay the same, they just switch where they are from row to column. So I'm not going to write out this definition because it's pretty common sense. We would say 2 matrices are equal to each other if they have the same dimensions and if all of the elements in the corresponding spots are also equal. So if 2 matrices are the same size and have all of the same elements or entries in them, they have to be equal matrices. So matrices have to have the ability to have math performed upon them, so different operations. So 2 matrices can be added or subtracted if and only if they have the same dimensions. So I'll write that out. So 2 matrices can be added or subtracted. And then of course subtraction is really just addition with a negative sign. So we're going to talk first about addition and subtraction. We'll build our core elementary operations, and then we'll get into there are 2 different kinds of multiplication with matrices. So we just have to be careful about that when we get there. So one example of how to add matrices together as if we are given these two matrices. So we've got 17, 23, 22, 30, and 17, 15 in our first matrix. So this would be a 3 by 2 matrix, and sometimes it's a good habit to get into is just write the dimensions of each matrix. That way you know what you're dealing with. And we are going to add that to the matrix 35, 15, 14, negative 2, 18, and 10. So all you do, it's pretty common sense, you just add all of the elements that are in corresponding locations. So to get our first element in our first row, we would add 17 and 35 together, and we would get 52. 23 and 15 is going to give us 38. I forgot to write that this is also a 3 by 2 matrix. 14 and 22 is 36. 30 plus negative 2 is 28. 17 and 18 gives me 35. And 15 and 10 gives me 25. And if we look at that, our resulting addition matrix also is a 3 by 2. So when you add or subtract matrices, the dimensions are going to stay the same in the answer. So now that we've covered addition and subtraction, we need to talk about something called scalar multiplication. So a scalar in math is just a number. It's a whole usually a whole number. It can be a decimal as well. It's just a real number. So in scalar multiplication, you are multiplying a real number into a matrix, or to phrase it a less awkward way, multiplying a matrix by a real number. Okay, so in order to do this, we're actually going to look at a word problem situation, which means I am going to actually switch to the next slide, so I have plenty of room to write this out. We're going to be talking about pizza, one of our favorite foods. So we have this guy named Peter, and Peter owns a pizza palace. So Peter's Pizza Palace sells... I'm just going to read the information and we're going to put it into a different matrix. So they sell 75 cheese pizza, 60 veggie pizzas, 90 sausage pizzas, and 80 supreme pizzas for lunch on Saturday. They sell 90 cheese pizzas, 100 veggie, 80 sausage, and 140 supreme pizzas for dinner on that same day. So we're going to first write a matrix. So we're going to write a matrix for Saturday sales. And if you're interested in visually seeing all that information, I got this problem out of your book. It's in section 12.1 on your textbook. So you can always look there for the actual numbers visually out. So we're going to write a matrix, and I'm just going to call it S for sales, or for Saturday, whatever one you want to deal with. So we have two different quantities here to talk about. We have what types of pizzas were sold, which was cheese, veggie, sausage, and supremes. And then we have pizzas that were sold at lunch and pizzas that were sold at dinner. So I'm going to make a 2 by 4 matrix here. And I'm going to let the top row be my lunch sales and the bottom be dinner sales. And then each column is going to represent a different type of pizza. So my first column is going to represent my cheese pizzas, and then we have veggie, sausage pizzas, and supreme pizzas in our last column. So I'm going to read it back again while I write in our information. So for lunch on Saturday, he sold 75 cheese pizzas, 60 veggie pizzas, 90 sausage pizzas, and 80 supreme pizzas. And then at dinner, he sold 90 cheese pizzas, 100 veggie pizzas, 80 sausage pizzas, and 140 supreme pizzas. Very popular dinner, apparently. So we can use matrices to organize numerical information. So now if I just go to an entry, say I pick 60, I know at lunch, since that's in my lunch row, and it's under veggie column, I know at lunch he sold 60 pizzas. It's just a way of organizing data without having to deal with all of the labels for each individual unit. So Saturday's probably a big pizza day for Peter, but Peter is expecting to only sell 90% of those pizzas on Sunday. So Peter is expecting to sell 10% less pizzas on Sunday than he does on Saturday. So maybe we want to find his expected sales. So again, we can use our matrices and our operations that we've talked about. We so far have addition, subtraction, and scalar multiplication to figure out, okay, well, what are Peter's expected sales for Sunday? So we know from Saturday's sales we have that matrix, and he's expecting to sell 10% less pizzas, which means he's going to sell 90% of the pizzas that he sold on Saturday. So I'm going to call our, I don't know, we'll use U Sunday. I don't know, Sunday's got a U in it as our Sunday sale matrix. And we know that that's going to be 90% or 0.9 of matrix S. So now we can see I have 0.9, which is a real number, times S, which is a matrix. So this is scalar multiplication. So what we're going to do is we are going to have 0.9, and then we're just going to copy down our matrix from above. So we have 75, 60, 90, and 80, and then 90, 100, 80, and 140. Okay, so now all you do is, it's just like in algebra, if you have a number outside of parentheses, you distribute it to everything inside the parentheses. When you have a number outside of a matrix, you distribute it to every single entry inside the matrix. So we're just going to do 0.9 times all of our entries, and I'll write out that multiplication, at least for the first part. I don't know if I'll write out all of it. So we have 0.9 times 75, 0.9 times 90, 0.9 times 60, 0.9 times 100, 0.9 times 90, 0.9 times 80, 0.9 times 80, and 0.9 or 90% of 140. So then all that's left to do for our scalar multiplication is to finish the multiplication part. So if we multiply all those numbers by 90%, we're going to get across our top row 67.5, 54, 81, and 72. And then in our bottom row, we're going to have 81, 90, 72, and 126. And so each row and column would still represent the same values that they did in our original matrix. So this 54 here in our first row, second column would represent at lunch on Sunday, he's expecting to sell 54 veggie pizzas. So now say that Peter is interested in finding out, well, how many pizzas is he going to sell all weekend? So if you were thinking to yourself, okay, we have his data for Saturday in a matrix, we have his data for Sunday now, at least his projected Sunday sales in a matrix. So his total projected sales for the weekend we could find easily by doing our original S matrix plus our U matrix, so our Saturday matrix plus our Sunday matrix. So just like when we did the addition example before, all you have to do is add those two matrices together. So we'll quick copy them down so that way we have all of our numbers next to each other. Maybe I'll try and write a little smaller so I can fit them all in the same line. That would be a good idea. Copying down our numbers from above. And then all you have to do is add them together. So to get our projected total weekend sales for each type and at each meal, we would have 142.5 cheese pizzas at lunch, 171 cheese pizzas at dinner, 114 veggie at lunch, 190 veggie at dinner, 171 sausage pizzas at lunch, and then 152 at dinner, and then 152 Supremes for lunch, and 266 Supremes for dinner over the weekend. So those are your basic matrix operations. You now have a worksheet on those basic operations to go over, so make sure you try each of those questions, and then we are going to talk about matrix multiplication in class tomorrow.